Okay, let's dive right into this explainer and completely transform how we look at the modern software-defined data center. We're going to go straight from those foundational physical wires to building an absolute, impenetrable virtual fortress. It's genuinely fascinating how this infrastructure actually comes together, so let's uncover it together. We're going to build this architecture block by block. First up, the vSphere distributed switch. Then, network virtualization with NSXT. After that, we'll get into securing that virtual network, and finally, getting complete visibility with ARIA operations. Section 1. The vSphere Distributed Switch, or VDS. This is all about building the network plumbing, our absolute foundation. Normally, configuring every single ESXi host manually is just incredibly tedious. But VDS acts as this super-powered switchboard that completely eliminates all of that manual work. By centralizing management, you just configure the network once, and it pushes that consistent configuration across all your physical hosts instantly. For scale, it's an absolute game changer.
It really acts as the central nervous system of your entire data center. You get NetFlow and port mirroring to watch traffic in real time. You've got LACP to bundle physical connections, so if someone accidentally unplugs a cable, traffic just keeps right on flowing. And you get VXLAN, which essentially lets you stretch a virtual network across completely different geographical locations. Now, what happens when there's a traffic jam? Enter Network I/O Control, or NIOC. It steps in like an automated traffic cop when the network gets congested. It ensures fair bandwidth distribution dynamically based on the type of traffic, so your critical services don't suddenly suffocate. When you break down how this priority works, it makes total sense. You absolutely have to give storage traffic, like vSAN and vMotion, high priority with high shares because they need low latency and high bandwidth. Conversely, you apply limits to the non-essential traffic. That prevents the starvation of your core services and keeps your business-critical systems online. Alongside network flow, we got to talk about compute mobility. So why does enhanced vMotion compatibility, or EVC, actually matter? Because it completely prevents downtime during hardware upgrades. By masking advanced CPU features so all your servers look identical to the virtual machines, EVC lets your workloads seamlessly jump between older and newer physical servers without dropping a single ping. If you're prepping for an exam, pin this to your brain. Bandwidth allocation through NIOC and CPU compatibility through EVC work hand in hand. They are your ultimate tools for keeping workloads highly available and dynamically balanced across your cluster. So we've built the plumbing, right? We've ensured our hosts can talk. But how do we abstract this hardware to build a truly boundaryless network? Because while VDS is incredibly powerful, it still ties us a bit too closely to our underlying physical hosts. And that leads us directly to our next major building block. Section 2, Network Virtualization with NSXT, the software-defined abstraction layer. Let's see how this builds our network entirely in software, completely detached from physical hardware limitations. It turns out NSXT isn't just for traditional virtual machines anymore. It's actually critical for modern apps, acting as the Container Network Interface, the CNI, for VMware Tanzu Kubernetes clusters. Working alongside tools like the AV Load Balancer for ingress traffic and Antria or Calico, NSXT creates these highly secure, isolated overlay networks for your multi-tenant pods. When we look at NSXT routing, we see two very distinct layers. Think of Tier 0 gateways as the massive interstate highways connecting your virtual city to the physical infrastructure outside. That's your north-south traffic. Meanwhile, Tier 1 gateways? Those are your local neighborhood roads, keeping traffic organized internally between your specific applications. That's your east-west routing. For large enterprises, NSXT Federation is basically a cheat code. It lets you centralize your global networking and seamlessly stretch your security policies across multiple data centers. This means if an entire site goes down, your disaster recovery strategy is flawless, simply because the exact same network and firewall rules already exist and are waiting at your secondary site. A crucial distinction for certification hunters: know exactly where a Tier 0 versus a Tier 1 gateway sits in your topology. Understanding how Federation scales active deployment models globally will completely change how you view disaster recovery strategies. Okay, so we have this amazing, scalable highway system now spanning across data centers. But what if a bad actor manages to get past the perimeter and onto that highway? We absolutely need a way to stop them dead in their tracks before they reach our critical servers. Section 3, Securing the Virtual Network. Armoring the Software-Defined Data Center. This brings us to wrapping our entire virtualized infrastructure in advanced, automated armor. Let's compare our firewall options here. The standard VDS firewall, that gives you basic layer 4 deadbolts for simple environments. But the NSXT distributed firewall is on a whole other level. It provides micro-segmentation with layer 7 application security. It's like putting a deadbolt on, actually scratch that, it's more like putting an intelligent biometric scanner on every single virtual machine's door, fully equipped with intrusion detection and prevention.
Moving down to the bare metal, VMware Trust Authority, or VTA, is incredible. It establishes a strict trusted computing environment by mathematically verifying the actual hardware of your ESXi hosts using a TPM and a key management server. If a host fails this math check, like, say, someone physically tampered with the server motherboard, your highly sensitive VMs will just say nope and absolutely refuse to run there. With the hardware security enhancements in vSphere 8.0, the protection gets even wilder. We can now hand a virtualized TPM chip directly to our Windows and Linux VMs to encrypt individual disk data at rest. Combine that with UEFI secure boot, stopping malware injection at startup, and encrypted vMotion protecting data while it's zooming across the network, and you've got incredibly robust workload protection.
Flashing the exam warning lights again for you, the key is knowing exactly when to use which tool. VTTA secures the physical host integrity via the TPM, while the NSXT distributed firewall uses IDS and IPS to stop those lateral, east-west threats between your workloads.
Section 4. Visibility with ARIA operations, sitting in the network watchtower. Now that our virtual fortress is built, highly fortified, and running smoothly, we need to climb up into the watchtower to actually see what's happening across all these layers.
ARIA Operations for Networks, which you probably remember as vRealize Network Insight, acts as our watchtower. It literally turns the lights on in a dark room, giving you real-time traffic visibility across both vSphere and NSXT. It analyzes your flow data, which is essential because it lets you perfectly map out your east-west traffic and tighten your micro-segmentation rules without accidentally breaking your applications.
This is your ultimate diagnostic tool. When a user complains that the network is slow, this is exactly how we troubleshoot performance, analyze flow data, and definitively prove whether it's an application issue or an actual network bottleneck. By mastering these building blocks, from the centralized plumbing of VDS through the boundaryless routing of NSXT, all the way down to the granular armor of microsegmentation in VTA, your data center becomes practically impenetrable. But it begs a serious question to leave you with. You know your physical hardware is secure, but if a sophisticated attack happened right this second, are your virtual borders truly locked down?